At the end of this video, we will have a CRUD Rest API built using the C# programming language, .NET technologies, Microsoft Entity Framework ORM, Postgres run into a container, and of course Docker and Docker Compose. You can see in this slide a recap of what we are about to build. We're about to implement 4 functionalities with 5 different endpoints, controllers. We have 1 for create, 2 for read, basically read a resource, update a resource, delete a resource. This will be the core of this live stream. So basically a C# application, Dockerized with a Dockerfile. We will test this app with Postman, but you can use any tool you want to test it. We will not download Postgres, but we will run Postgres inside the Docker container, and we will link these 2 containers, services, using Docker Compose, a Docker Compose file, and the Docker Compose CLI. So how can we, the requirements are, you need the .NET CLI, so let me go here. So here you should have .NET CLI -- version, the .NET on your machine, and of course Docker installed on your machine, Docker -- version. Okay, so you will have Docker, this version of Docker. Nice. And also in this episode we will not use Visual Studio, but we will use Visual Studio Code. So I highly recommend using an extension called C#. It's the most famous one in the extensions. Or you can use any IDE you want. So how can we initialize a C# project, ASP.NET project? We can use the command line, this .NET command line. I have the command here, but before do that, you should put yourself in a folder on your file system. For example, I'm in C/workspace/live, and from here we can do .NET new web API -n, which stands for name, for example, C#-CRUD API. And we will see that this is super fast. It creates a project literally in seconds. Now we should step inside this folder. Okay. And something that we may do suddenly is this to install the dependencies. So .NET add package, we need 2 dependencies. One is the Microsoft Entity Framework core, which is basically the ORM. It will help us to interact with the DB. And one is the connection with the Postgres container. So this is the one. I'm copy pasting this. I'm not going to risk typing this. So let's add this dependency. It's super fast. And let's also add this other dependency, .NET add package, npg SQL, etc., etc. Nice. Now let's open this project. So let's do. You can open this with any IDE you want. If you use Visual Studio Code, you can do code space dot, and we have this. To test it, we can just type in any terminal .NET run. We will see here something strange. .NET run building. Okay, it published this on a random port, localhost 5038. But if I click here, something strange happens. I've been fighting with this for a while because here we have empty page, localhost page not found, can't be found. But it seems that like the server is up and running. Otherwise, I would not get this this sort of error, which is from the server. So to actually see something, I should go on /weather forecast. Don't ask me why it's like that, but we need to go on this endpoint, which is basically getting some information about the weather. The reason is that here we have this sort of mini controller, which is a weather forecast. Okay, that's it. And we have also this. This is the controller, and this is to have the the model of the weather. So this is something a bit strange to start because there is not any sign of this endpoint to use. But anyway, this is how you can start. Now let's start configuring our application, and the first thing that we should do, we can stop this one. The first thing that we should do is to configure our app settings.json. Just a moment here. Okay, and okay, so here we need to add another configuration, another key. And we need this sort of connection string. I'm copy pasting this, but everything, all the code will be available on GitHub after this. So this is just for me to avoid making a typo. So connection strings, default connection, and let's see these keys. We have as a host DB. I'll explain to you later what is that and why we don't have, like, for example, a static an IP. The port of the database we want to connect. Usually the Postgres is 5432. As a database, Postgres, which is the default one, the username Postgres, and the password Postgres. Don't use this in a production environment, but here we are just doing an example, okay? Nice. Now we have to start creating all the logic for this application. How can we do this? We need to create some files, 3 files. Let's create a folder called models. And inside this folder, we can create a file called user.cs. This is a C# file, which will contain a C# class, let's say C# class on steroids, because this will have some decorators. I'm not sure they are called like that in C#. So first of all, let's define the dependencies of this file. So system.component model data annotation, because we want to use some data annotation, and I'll explain you why, because this is a bit strange. So the namespace is okay, but here I want to define a table users, and now I'll explain you why. Because by default, and here public user, so by default the tables of C# using Entity Framework are with a capital letter. I don't want this. I want the name of the table being lowercase. So I have to say this explicitly, both for the table and for the columns. And I just need an ID, a name, and an email. We can just remove the password, but here also, no, this is okay. Column ID, name, and email, you see? Otherwise, it will create email with capital E, name with capital N, ID with capital I, and I don't want this. I want to have everything lowercase, and I think this is a good way to do that. Now, let's create another folder. A folder, you can see here below my face, a folder called data, and inside this we'll create a file called usercontext.cs. Okay, so this is basically to have a connection with the database. So we can say using models, so we are using this model that we just created, and then we can use the Microsoft Entity Framework core. Okay, and here we can have this namespace data, public class user context, db context, and this is the constructor user context, db context options, user context option space. So we will leave this with the default one. Nice. This is done. Now we need to create a controller. This will probably be the hardest part, at least for me. So let's create a file called users controller. It can also be user, but let's say users controller.cs here. So this is a controller. This will handle all the requests. So here we have some dependencies. So let's some import, let's say. So we have this data. Data is the folder that contains the context, the Microsoft ASP.NET Core.mvc, the models, which contain the users, the Microsoft Entity Framework Core, and then the namespace that we can copy paste from the other controller here. Let's Okay, so we have the same namespace. Now, I really like the syntax of C# for this controller. Let's see, and of course, let's use GitHub Copilot and I'll try to explain what's going on. Let's see if how straightforward it is. So, we are saying that this will be an API controller, and as a route, we can use the API / controller. The controller will be users, but this is like a generic one. So I think the controller is using the name of the table, but I'm not sure. But it will be /users. And now here we can have a public class. Here I don't know why it's never helping me the GitHub Copilot. And here it will be a controller base. Okay, nice. So users controller base. Now we need to inject, we need to use the dependency injection. Okay, this is a bit too much. Private, read only. And we need to import this user context. And then define constructor by using this context. Okay. Now we need to, as I said, we need to create the 5 controllers for the 4 functionalities. We'll have 5 instead of 4 because we'll handle the get all and get just one user with 2 different functions. We can also handle we could also handle the same the functions of getting all and getting one with just one function, but I prefer to have them separate. So when we do hit /API users, okay, I really like the syntax. This is an HTTP GET, so basically this will be on a get request verb, and this is very straightforward. We have this asynchronous function that will return a list of users. I really like the syntax here. And then, one moment. Nice. And nice. Yes, it's very similar to Laravel. Yeah, to be honest, yes, it is. And now HTTP to get, let's get to one single user. So we want to, for example, when we go on /API /users/3, we want the user number 3. And this GitHub Copilot here, it does really an amazing job. So we get this asynchronous function, and we get this user. We'll find asynchronously this user because it's in a database. And then if user is null, then we return the not found, which is basically, I think it will be a 404. Otherwise, we return the user. Really like the syntax here. Now, to create a user, usually we don't do a put request, but we do a post request. And so HTTP post. And here we can create the users like this. So we have a user as a body, and we do this in the context. We can save this user asynchronously. Very, very straightforward, and really like the syntax, even if I'm not used to the C#, to writing C# code for a while. Then, to modify user, we need the new body, but also the ID of the users we want to modify. So, for example, if we go on API /users/5 and we provide a new body, we will have the new user 5 with the new values. So I think that this is correct. So this is an asynchronous function. It will take a user in input. Now, if the ID must be is the same as the user ID, so we need to pass the ID here when we want to change the user, but there is a check here. And then it says basically the context. I think it's the same function. Okay, perfectly. So it's 100. And then to delete a user, when we go on API /users/2 with a delete, we will delete the user number 2. So this should also be okay. Synchronous function will find the users. Before, of course, we can't delete a user that does not exist. If a user does not exist, it says not found because we can't delete a user that does not exist. Otherwise, we just remove. And we'll see who these functions are because we have this underscore context. What I also want to do before we keep going is to add a dummy endpoint. Why? I want to do this because if I have any problem, I have /API /users/test, and this we should just return sync. No, this is just a public string. Just hello world, okay? So in this case, so /API /users /test, we should return hello world without interacting with the DB. Perfect. Now we need to inform the application that we have this new controller. So we can go on Program.cs and we can we can import the using data. Then we can import the Microsoft Entity Framework core. Okay, I really like this framework. And then here in the in this part we need to add the service for the connection with the database. So how can we do that? Before building this, we can say var configuration builder configuration, okay? And here it should be okay, builder.services add db context user context option use mpg. You see here this mpg SQL, this is saying that it's Postgres, okay? Default connection. Nice. So we just built all the application. Now we need to do the Docker part. So it will be very simple. We'll create just a Dockerfile and a Docker Compose. Dockerfile. Okay. So in this Dockerfile, I want to show you something maybe for the first time, which is a multi-stage build. So we'll have, instead of just one from, like two froms, and I'll show you, it's easier. So from MCR, which stands for Microsoft, we are using the Microsoft registry, Microsoft com.net, it's not core, it's SDK 7.0 as build. So we have this base image as a work dir, a default folder inside the Docker image. We can have, basically we are copying the CS proj like this. So basically this file, C# CRUD API as project, we put a star so we don't have to put the exact name, and this works basically for all the C# projects. Then we run the restore, and then we copy everything else. So everything which is in this folder. If we want to ignore something, we can add them to Docker ignore. We're not doing this in this example. Then we can run .NET publish. So basically we will, at the end, we will run a DLL file, and then from. And then here there is another from. So this is the build, and then we have the runtime. So mcr.microsoft com.net ASP.NET 7.0 as runtime. And here as a work dir, always /up, and then copy from build up out. So we copy everything, and then last step is this. We do .NET and then the name of the DLL file that will be generated, which will be C# dash CRUD dash API .dll. Perfect. So this is the Docker file. Okay. Nice, Eddie. Mr. Semicolon. I don't take you seriously. Nice. Now, Docker file, Docker Compose, Docker dash compose.yml. Nice. So let's create this Docker Compose. We have done this multiple times already, and one part will be the same, but let's see. Okay, so version of the Docker file. I think the current one is still 3.9, and this should work with everything which is 3.x. And then we should define the services. Services are basically containers, okay? C#. So we need two containers. The first one is C# up. It's a bit hard to pronounce. Then container name C# up, C# up. The image, it will be Francesco exec, which is my Docker Hub, C# up 1.0. Then the build, we want to build here in this folder. And then the ports. The ports, it will be interesting. The ports are 8080 on that side, but inside it will be 80, because since we are publishing, this will be published on the port 80, but I don't want to run it on the port 80 on my machine. It could cause some problems, so I will publish on the port 8080, but internally it will use the port 80. Now, we need to define the environment variable here, and as environment variable, we need to define the connection string, so connection strings, okay, connection strings default connection. I think this is a convention of this double underscore, and then here as a host, not Postgres but DB, you will see why soon. Postgres, okay. Now depends on DB, the service DB, and I think we are done. Perfect. Now, what is this DB? DB is the service that will run the Postgres container. So let's start with this one, container name. Postgres, I use version 12 because I'm sure that it does work. And then the port 5432. And here, the volumes. So we need to define a volume to persist the data here. So pg data. And in the volumes here, we can see pg data. Bam. So this should be done. Now the hard part, because I don't know if this will work. Let's see. So, okay, so first of all, let's see if we have everything set here. So Docker.ps-a, I see, perfect. Let's, nice. So the first thing that I want to do is to run the database container. We will create the table manually for this example, because this is how I managed to do that. So docker compose app -d, which stands for detached, db. Bam. In the meanwhile, we can go here, we can do clear, we can open the other. Okay, so Docker.ps-a, Docker.ps-a. Okay, we have this Postgres container up and running. Now, let's step inside this container. This is very important. Docker exec, for example, we can do this in this way. Docker exec -it, db, which is the name of the container, and then any command. For example, psql -u Postgres. Okay, and we are inside the container. You see Postgres with this, and then we can do /dt, and we see that we have already this this table. The reason why we have this table is because I'm attached to the volume that was already there before doing the live stream. So let's so this can happen because I used the same volume. So to remove a volume, it's very easy. You can do docker compose down -v. We should start without, I want to start clean. This should work anyway, but let's start clean. So docker compose down -v, it removes all the services and also the volume. Let's start over again. And now we will see here, let's clear, so it should be clear. Okay, so /dt. So this is how it should look on your machine. So don't have any relations. Perfect. Nice. Now the hardest part of the live stream, which is the Docker Compose build. Docker Compose build. So I want to build the image that are defined here. It will build not all the images, just the images that have a build key, or not build the Postgres image. Doesn't make sense because I'm using something already which was already used by someone else. Now let's see. Okay. This is already a good sign. Now let's run it and let's see. Docker compose app. Now Docker compose app should be already enough, but I want to be super clear, and I want to say Docker compose app and the name of the service. We don't really need this, because if you do Docker compose app, it will run basically all the containers. But I want to say, okay, I want to run this here. You can try Docker compose app, it works anyway. Let's see. Okay. It seems that it worked. So we have this container up and running. Now, the first thing that I want to check is here, what happened to the Postgres container. If I do /dt, okay, we don't have any relations. The reason is that in this example, I don't have any ORM that synchronized the models. So I have to do this manually. So how can we do this? We can just use a SQL command. For example, this one, create table users, ID, name, and email. I want to add this in the file here, so this will be easier for you if you clone this repository. So you can test SQL. So this is the SQL command, okay? Here. Okay. The only thing is that this should not be capital. So let's do this and this. Perfect. So, okay. So create table users, ID, name, and email. Perfect. Done. And now we have, of course, so select star from users. Nice. Now let's check here all the services. So if I do Dockerfile -a, nice. It looks cool. Now let's just test these services. So the first thing that I want to do is go on port 8080 /API /users/test and see if I get any response. Yes, I get hello world. This is a very good sign. It means that the controller of the users, it was good. It was good. Now, let's make all the tests. So let's get the users. Here we see an empty array, which is correct because we don't have any users, but having this, it's a very, very good sign. Now, let's create some users. Let's put some names here. Okay, let's put, you can put your name here in the chat. So we can have Eddie for sure. This is Eddie mail. So Eddie will be number 1. Yeah, post request 8080 /API /users. Nice. Eddie number 1. Now something else. Let's see. James email. Let's create 3 users. Usually create 3 users. 1, 2, and let's see. Mujawal. Okay, I hope I pronounced that well. Okay, nice. So we have these 3 users. Now let's try to get all the users again. Let's see what do we have. And yes, we have the 3 users. Now, to get a single user, you can go on here, you can see users /2, for example, to get James. Let's see if we get James. Yes, we have James. Now, let's modify. So, for example, instead of James, we can have Studio. I think I can put a space. I'm always scared to add spaces. Okay, so let's modify this, and I remember that here it has this check that I have to put this ID. Okay, but it will check that this ID is the same as this ID. So James should go away, and we should have Rest Studio. Let's see. Okay, we don't have an answer, but you can see here in the request, we have in the response, sorry, we have a 204 with no content. It means it's a good sign. So if we try to get these users again, now we have Rest Studio mail, and if we want to get all of them again, let's do it. Okay, we have these 3, and you can see Rest Studio has changed. Nice. Last test, users. Let's delete the user number 1. So let's delete Eddie, just from this app, of course. Status 204, which is a good sign. We don't have a request here, but it's okay. Let's try to get all the users again. Perfect. And we have user 3 and user 2. Done. I want to show you just a couple of more things. Here in the Postgres 1, we can do now select star from users, and you can see we have this one and this one. Before we go, I want to show you also how we can test this with another tool, which is, for example, TablePlus, but you can use any tool you want. So we can create a new connection. The host here will be localhost, because this is not running in a container. The port is 5432, the user Postgres, the password Postgres, the database Postgres. Let's connect. And here, I don't know if you can see, we have a table, users, and here we have the same values. Let's studio image. Perfect.